revolution in spaceflight opens a future of limitless possibilities. Not only prove that it's possible for a well-led entrepreneurial team to do things that it was previously thought that only the governments and superpowers could do, but do it in a fraction of the time, at a tiny fraction of the cost, and even do things that they had deemed out of the question.
We often say that we stand on shoulders of giants, and that certainly is the case in the work that I'm doing today. This is a historic year. 50 years ago, this past May, the Skylab 1 crew entered Skylab and really started our first foray into longer duration missions.
We have a lot of vehicles that we are in the midst of building. We have our flight surgeons and our folks weighing in on the human factors and human systems integration of these new vehicles in development. We try to make sure that they are designed with the human in mind and work with our engineering and safety counterparts on the development of those new vehicles.
I like to think about space stations as an evolution, starting with Skylab, evolving to ISS, and then bringing us to Gateway. But Gateway, it's going to be our wonderful space station orbiting around the moon that balances between the Earth, moon, and sun, that requires a minimal capability to maintain that orbit. We're doing science on Gateway 24/7, 365. It's really a central hub as that station where crews will go to and then step off in the future to the lunar surface, or like I mentioned, moving on to Mars as well.
We'll be doing a lot of science, but also a lot of testing of industrial engineering, power plants, even nuclear power, potentially on the moon, to get us prepared for the ability to live and work on Mars. A lot of why we're going to the moon is to use the moon as a test bed for Mars.
Apollo was wonderful missions in the 70s. It were scouting missions. And now for that next phase in Artemis, expanding human exploration, going on to the moon, and our horizon goal, if you will. And that is building those capabilities and technologies to set those first boot prints on Mars in the not too distant future.
There's now a whole raft of entrepreneurial fusion power companies that have gotten funded. These machines are being built, they're being tested, and I believe they will create workable fusion ignition systems this decade. Fusion rockets have a unique province because a fusion rocket could get an exhaust velocity of 7% the speed of light, which means a fusion rocket could get up to about 10% the speed of light. We're talking about a beginner's capability for interstellar travel.